Hi, I'm near St. Cloud, Manitoba. I'm here with Dr. Henrique Carvalho. He's the Assistant Professor of Agricultural Meteorology in the Department of Soil Science, University of Manitoba. Henrique, here today we're standing beside one of 6 Flux towers that you have installed in Manitoba. What do these Flux towers do and what are they measuring?
And yeah, this is our one of our 6 Flux towers, as you pointed out. And with this instrumentation, what we can do is we can measure how the land surface, whether it's a crop, a forest, grassland, exchanges essentially carbon dioxide with the atmosphere, water with the atmosphere. So we can make those measurements at a very high temporal resolution. So by that I mean every 30 minutes we can calculate those values, right? Which gives us the daily total, let's say how much water the crops were using, how much CO2 they were taking up for their growth, and essentially 365 a year essentially. So we can keep doing those measurements for a very long time.
Okay, so part of your studies are in micro-meteorology, which is kind of like the environment, shall we call it, at the ground level as it pertains to different crops. Can you talk a little bit about that, please?
Yeah, so micro-meteorology is a discipline. I guess that description that you used is very accurate, is the climate near the ground, if you want to think about it that way. But it's more than just measuring the temperature at a certain location or how much rainfall there was at a certain location. It's about the exchanges. How much water, how much CO2 it is exchanging with the atmosphere. So we go one step further, and what we try to quantify is at the local scale how the plants that are growing are being influenced by the weather and the atmosphere in general, and how the field itself influences the atmosphere. So we make those kinds of measurements. That's part of the work that we do.
Right, and part of having these installations in different sites too is because they are measuring different crops from each year to year. This one is an alfalfa field. I believe not too far away you have one going to be in a canola field soon.
Exactly.
And then corn as well. So do those microclimates vary greatly between each other?
They are fairly close to each other. So in terms of the general climatic patterns and weather patterns, they're experiencing the same. But how they are interacting with it is different, because those are different plant species, right? Different crops. So while here we already have green vegetation that is actively transpiring and doing photosynthesis and growing, the cornfield has barely emerged just yet. Essentially not a whole lot of activity. So essentially that interaction, right? That's what we're trying to study, is how those different crops they interact with the atmosphere to grow and develop, right? And that is the reason why we make those measurements, to understand a little bit the limitations to growth, right? How those crops are being limited by things like soil water deficits, for example, right? And how that is essentially impacting, let's say, photosynthesis, right? Which is ultimately the source of all the carbohydrates that are going to be the crop yield, right? The vegetation biomass and stuff like that. So that's part of what we're trying to understand, is that exchange there, and how different plant species, how different cropping systems, if you will, interact with the weather and the atmosphere, essentially.
So Dr. Carvalho, of course behind us here is one of your Flux towers. Tell me a little bit about each instrument that's on here and what it does.
Okay, so there are 2 instruments that are essentially the core of what we call the Flux measurement system. The first one is called a sonic anemometer, and essentially it measures the wind speed in the vertical and the horizontal directions, essentially in all 3 dimensions, right? And that is very important because it tells us when there is a downdraft, an updraft. It tells us not only the direction but the velocity. Then next to it we have what is called an infrared gas analyzer. We call that a NIRGA. And the instrument that we have here, it measures concentrations of carbon dioxide, so CO2, and water vapor. And the whole idea behind these measurements, these flux measurements, if we know the direction of the wind speed, right, the velocity with which it's moving, and we know the concentration, we know if the molecules, right, of CO2 are moving towards the surface or away from the surface, if water vapor is moving towards the surface or away from the surface, and that is essentially our flux, right? So if you think about in a day like this, that it's sunny, you know, mild temperatures, the plants are active. Every time that there is a downdraft, because the plants are doing photosynthesis, the air close to the canopy is depleted in CO2. So we see a downdraft and it's CO2 rich air. And when there is an updraft, it's the opposite. It's air that has less CO2 because the plants used it for photosynthesis. So by tracking this vertical movement, right, we can tell the amount of carbon that those plants are taking up during their growth cycle and things like that. The same for water, right? So when there is an updraft, the plants are transpiring, so there is a lot of water vapor close to the canopy, right? And essentially, when there is that updraft, it has a higher concentration of water vapor, so that's the evapotranspiration rate. And the opposite is true, right? The air is much drier than really close to the surface. So when there is a downdraft, it's dry air. So by tracking how much is going up versus how much is going down, we can calculate how much photosynthesis the plants are doing, how much carbon they are storing for growth and development, and how much water is being used in doing so. So that's kind of the core instrumentation for this method. So you can think of it as a weather station in steroids in a way. And then obviously we have another number of what we call biometeorological sensors that help us measure the biological activity of the field, right? So we have things like sensors that measure solar radiation in a specific wave band that plants use for photosynthesis. We measure things like NDVI, surface temperature, soil water content, soil temperature, a number of other variables, right? That helps us understand and relate those fluxes that we measure to the biological activity of the field, essentially.
Well, thank you very much for sharing your time with me and telling me about your project out here. Pleasure meeting you, Henrique.
Yeah, thank you, Greg.
Have a great day.
Yeah, you too.